Welcome to tonight's talk. I am Karen Taylor. I'm Program Director of the General Society of Mechanics and Tradesmen, and I'm really delighted that you can join us this evening. For those of you who may be less familiar with the General Society, a brief introduction. The General Society of Mechanics and Tradesmen of the City of New York was founded in 1785. Since then, our 235-year-old organization continues to serve and improve the quality of life for the people of the City of New York through our educational and cultural programs. These include our tuition-free Mechanics Institute, the General Society Library, which actually celebrates 200 years in a few weeks, the John M. Mossman Lock Museum, and our lecture series, for which, of course, tonight's lecture is part of. Before we begin, I would also like to express our thanks to Erin Holohan Haskell for all her help in promoting this lecture from heatinghelp.com. During the lecture, there will be an opportunity to submit typewritten questions through the Q&A section. And at the end of the talk, we will answer as many of these questions as we can in our 10 to 15-minute Q&A session. Now, we are so pleased this evening to have our speaker, who is Dan Holohan, because not only is he the international authority in steam heating and hydronics, but we're also very honored to have him as president of the General Society of Mechanics and Tradesmen. Dan, for the last 4 years, has come out specially out of retirement to give a talk related to steam heating and hydronics at the General Society. During these talks, fans of Dan's work and expertise have come as far away from Cambridge, Massachusetts to attend our lectures and hear Dan talk in person. And I hope that one of the advantages of our Zoom talk tonight is that there may be other attendees who live geographically far, far away, but are able to participate with us online this evening. Tonight, in this special talk, at a time when environmental impact is of critical importance, Dan will describe how steam heating is supposed to work and how to initiate green programs that overhaul existing steam systems for maximum energy efficiency. Dan Holohan began his love affair with heating systems in 1970 by going to work for a New York-based manufacturer's representative who was deeply involved in the steam and hot water heating business. He studied hard, he prowled many basements and attics with seasoned old timers and paid close attention to what they had to say. Mr. Holohan founded heatinghelp.com in 1997. His daughter, Erin Holohan Haskell, now owns and operates this extensive resource. He's also the author of dozens of books, including Greening Steam, The Lost Art of Steam Heating, and We Got Steam Heat, and hundreds of magazine articles about heating systems, old and new. Prior to his retirement, he was an established speaker in high demand on the seminar circuit, having taught more than 200,000 people. What a remarkable number. It is now my huge pleasure to introduce to you this evening, Dan Holohan. Thank you.
Thank you, Karen. So good to be here. Thanks everybody for coming by. When I was a young fella, I got very interested in steam heating, mainly because there was so much of it, and just about everybody I asked about had no idea. They thought that the banging and the spitting and the high fuel bills were normal. That didn't seem right to me, so I sought out the old coots. Most people don't want to listen to old coots. And thank you for listening to me, by the way. But I wanted to listen to them. So I went out looking for them. One day I asked this old fella to teach me. I want to learn about the steam, I said. He smiled and said, Dan, you already know all that you need to know. You just don't know that you know it. Huh? It's all basic physics, he said, and it comes with a few simple rules. I asked what those were. High pressure goes to low pressure, he said, always. Well, I knew that because I owned a bicycle pump when I was a kid. Pump it up, stop when the tire has enough. High pressure goes to low pressure. Okay, I got that. Then you press the Schrader valve if it's too much pressure and the air comes out of the tire, because high pressure goes to low pressure always. And then I started to think as I got older and I got my driver's license, what happens when you go to the garage to check the air in your tires? And you really should do that. You go up to the compressor and you set it at, say, 30 pounds of pressure, and you hook the hose up to the tire, and it goes ka-chunk, 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 ka. You never get that last chunk in there. What makes that compressor stop? Often wondered about that because there's no electrical connections between the compressor and the tire. So started to think about what's going on here, and I began to realize that when the pressures equalize, when the pressure in the tire is the same as the pressure in the compressor, everything stops moving. And that's got a lot to do with steam heat, because you see, no fluids move unless there's a difference in pressure. You can't move water, you can't move air, you can't move steam unless there's a difference in pressure, because high pressure goes to low pressure always. So I got that. And then the old timer back then, he said to me, the other thing you got to remember all the time is that water flows downhill. Always. And I said, okay, I knew that because I spilt a lot of stuff when I was a kid. My mother used to smack me for that. All liquids flow downhill, and that includes condensate. And by the way, if you don't know, that's what we call the liquid water that appears when steam condenses. We call it condensate, and it's going to flow downhill. Always. You can take that to the bank. And he also told me that steam is lighter than air, always. It's kind of like helium in that way. And I never considered that. But I learned that it's very important to steam heat. You ever notice how the steam goes to the top of the radiator when it enters? It has to. It's lighter than air. Steam and air won't mix. They're of different densities, and that's really important to know. One of the other things he told me is that vacuum sucks. Always. And it's true, vacuum does suck. When the steam condenses inside the system, it shrinks. And when it does shrink, it creates a vacuum, which you need to break because it can cause a problem. But if you're smart, you can also put that vacuum to work for you. And I'm going to tell you about that later. This is really good stuff. So years passed and I got older, and it was my turn to make up some aphorisms of my own. So I came up with what I decided to call the first rule of steam heating. And it goes like this. When you do something stupid, you will always be rewarded in a small way, which leads you to do things of much greater stupidity. An example. Every steam system ever made is open to the atmosphere. So these things are breathing. When the steam forms, it expands and it pushes the air out of the system through the air vents, and then gives up its latent heat to the radiators and the pipes, and then it shrinks back down. It's like a bellows. And when it shrinks back down, air comes rushing back into the system because the steam is creating a vacuum. So you've got this constant exchange of air moving in and air moving out. It's breathing just like we do. And because it's touching steel and iron, you've got wet conditions and the air comes in and you start to get rust. So what happens after a time is these particles of rust fall down inside the pipes, inside the radiators, and the steam is moving very quickly, and it picks up all that junk and it pushes it right toward the air vent because the steam is always looking for a way out. So time goes by and these air vents get filled with dirt and they get clogged. So now they're not air vents anymore. Now they're just sitting there and they're stopping the air from venting. They're like pipe plugs. So we get cold out because there's no heat in the building, or there's uneven heat in the building, or it's taking forever to heat. And we go there and we feel the pipe is hot up to this point, but then it starts to get cold. So we're thinking what we need in this case is more pressure. So we go down to the boiler room and we crank up the pressure. That's the stupid part. Because when you crank up the pressure, all you're doing is compressing the air that can't get out because the vent is plugged. But the steam does move a little bit further down the pipe. You see, that's the reward. You did something stupid. The pipe got a little bit hotter. That's your reward. So you go back down to the boiler room and you crank the pressure up even more. And after a while, you're cranking the pressure up till the relief valve's popping, and then you change the relief valve. When you do something stupid, you're always going to get rewarded in a small way that leads to things of greater stupidity. You will never heat that building unless you fix those air vents, because you can move with a pinhole what you can't move with a ton of pressure. Steam and air have different densities. That's what the old man taught me. A few years back, I got to go to the Arsenal. If you don't know what the Arsenal is, it's that beautiful old building that sits by the Central Park Zoo, right across from where the seals are. And growing up in New York, I mean, I was walking past that building all the days of my life, never realizing that that building is older than Central Park. It used to be an arsenal. And when they decided to build a park, they turned that building into a police precinct. And then it became the Museum of Natural History while they were building the real Museum of Natural History on Central Park West. And then it became a police precinct. And then it became the Weather Bureau. And then it became Robert Moses' office. And then it became one of the Parks Department buildings. And it's one of the 2 Parks Department buildings in New York that runs on Con Ed steam. And some friends that work for the Parks Department asked me to take a look at it because it was taking 2 hours from when they turned the steam on for the steam to get to the top of this building, which is only, what, 4 or 5 stories? Not even 5, maybe 4 stories tall. 2 hours. So I went there and we met, and we started at the pressure reducing valve station where the steam comes in from the street. And we got a bright flashlight and a ladder, and we just started to follow the pipes. Now, this building has 2 pipe steam, which means it has steam traps on every radiator. So we followed the pipes down, and we were going into people's offices and excusing ourselves and telling them that we were there to fix the heat. And when we got down to the end of the main, which ran across the ceiling, there were float and thermostatic traps, which is normal on a steam system. And then the pipe turned around. This is going to be the return line working its way backward, and it's paralleling the steam main. So you got the end of the steam main turns around, it goes back the other way. Now, anything that's flowing into that return pipe is coming off of a radiator that has a steam trap. So that line is completely trapped, and all the traps were working. But when we got back down to the end of the line, there were more float and thermostatic traps. And I said to the guys I was with, they're not supposed to be here. You've double trapped this line. And the guy said to me, but they've always been there. I said, that doesn't mean they're right. Sometimes just because it's always been there, it doesn't mean it's supposed to be there. I said, what's happening here is when the traps at the end of the main shut, there's no longer any pressure beyond that point. So now you've got this long pipe that runs the whole length of the arsenal. And at the end of that, there's another working trap, but there's no pressure to push the water through that second trap. So that pipe is filled with water. And you can't vent air through a pipe that's filled with water. So I said, what you need to do is just take those 2 traps out. So that didn't take long. They went and got a ladder and some wrenches. They took it out, put everything back together. We turned the steam on, and it took 10 minutes for the steam to heat the whole building. And I felt really good that day. You know why? Because I grew up in New York, and I passed that building so many times when I was a kid. But on that January day when I visited there, I felt like I was leaving a piece of me there. And now whenever I go by there and I see the Delacorte clock with the animals swirling around, I'll say to myself, I helped that building. That's a good feeling. So don't do stupid things. Sometimes you're not thinking that it's stupid, but stupid is the enemy of sustainability. And how can you tell the difference between stupid and smart? Well, to do that, you have to start thinking like water, and you have to think like steam, and you have to think like air. And as you do this, you have to ask the question, if I were steam, what would I do? And then you ask the same question of the other 2 participants, water and air. If I were water, where would I go? What would I do? If I were air, could I get out? And could I get back in? That's the question I kept asking as I walked through the arsenal. If I were air, could I get out? And you just look for a vent, because steam doesn't know up from down, and neither does air. It's just looking for a vent. And if you don't see the vent, that's the problem. So first, let me explain what steam is first, because I think you probably think it's what's coming out of a tea kettle, but it's actually that little bit just before you start to see it. It's that invisible stuff, because good steam is as clear as air. So if you were to take a pint glass and instead of filling it with good cold beer, just fill it up with good cold water, that's going to weigh about a pound. Now pour that into a pot and turn on the stove. But first know this, 1 British thermal unit is the amount of heat it takes to raise 1 pound of water, which is about a pint, 1 degree Fahrenheit. Meaning that if you were going from 32 degree Fahrenheit liquid, not ice, but liquid, to 212 degree Fahrenheit liquid, not steam, you would need 1 BTU for each degree of temperature. So you need 180 BTUs to get from 32 to 212. But that's not steam. You now have 212 degree water, because steam is one of those rare things that can exist in a solid, liquid, or it's the only thing on the planet that can exist in solid, liquid, and gas. And it's the only thing that could be like the same temperature in different states. So now we've got the water at 212 degrees, but we want to make steam. So to do that, we have to add an additional 970 more BTUs per pound, which is more than 5 times what it took to get us from 32 to 212. And once you add the 970 BTUs to that pint of water, you now have steam, but it's still at 212 degrees. And this is the stuff that heats the building. You don't need a lot of pressure to heat a building. You just need this latent heat. And when the steam does hit that 212 degree point where it turns to steam, the water, I mean, when it turns to steam, it's going to expand 1,700 times. So this stuff goes off bigger than microwave popcorn. It just blows out, which is beautiful. And that's also sustainable because it goes out into the building at 60 miles an hour. That's the design velocity for steam heating. The only thing standing in the way is air that's not getting out fast enough because you don't have the right vents. And as steam is going out, it doesn't need any pumps. So we save the money on the pumps and we save the money on the electricity. Steam goes off there by itself. And it doesn't take much water to fill the system completely with steam. But the kind of steam that you're sending up into the building is also very important because there's 2 types. You've got dry steam, which is the good stuff. And in the old days, when they made these really big steam boilers, a boiler couldn't get a rating from the manufacturer, couldn't get an approval unless it produced 98% quality steam, which meant that in the steam, there was no more than 2% liquid water. That's the dry stuff. That goes out into the building. It doesn't condense on its way to the radiators very much, and is carrying all this latent heat energy up to where you need it to be by the people. Wet steam is steam that's sloppy. It leaves the boiler and carries a lot of water with it. And the water then takes the latent heat out of the steam and stops the steam before it gets to the radiators. Usually when this is going on, it's a result of the piping being bad, or the boiler being improperly piped, or the water being dirty. And the usual solution is somebody will come along and raise the pressure. That's like the universal cure for anytime there's a problem, raise the pressure. That's the worst thing you could do, because the wildest thing about steam pressure is the higher you raise the pressure, the slower the steam goes. Steam at 0 PSI travels faster than steam at 10 PSI, and steam at 10 PSI travels faster than steam at 100 PSI. So if you want the building to heat, you don't raise the pressure, you lower the pressure. And when the wet steam kills the water in the wet steam kills the steam, that's when you have problems and you're not heating the building. And you can see that in the gauge glass. When you're looking at a gauge glass, the level of the water above, the gauge glass above the water level should look like somebody just ran a dish towel through it. It should look bone dry. You shouldn't be seeing water there or bubbles or water surging over the top. That's an indication of wet steam. And that's often done because the boilers that are made nowadays can't produce dry steam internally like they used to in the old days. Back in the day when the boilers were big and very inefficient, they had very wide sections through which the water can disengage, the steam bubbles can disengage from the water without dragging a lot of water up into the building. During the 70s, when energy became a big deal with the OPEC oil embargo, we began to make smaller and smaller boilers. And that space that the steam is forming got smaller and smaller and smaller. And yet we were making the same amount of steam in that area. So that led to water being carried off into the building. And the way around that is you really have to follow the manufacturer's instructions, because they're all tuned into it these days. They weren't so much in the 80s, but now they are. And you've got to pipe it in a way that the boiler manufacturer says, because the near boiler piping, that stuff in the boiler room, is going to separate the water from the steam. So if they tell you you have to be so many inches off the top of the boiler before you go into the boiler's header, take that seriously, because they really mean that. And the people that really are good at steam heating employ what's called a drop header, which is where you come out of the top of the boiler and you go up as high as you can, and then you turn and you come down and you place your header at a lower level, and from the header you pipe it off into the system. This height that you're giving the steam allows the water to drain back into the boiler. And if you visit heatinghelp.com and just do a search on drop headers, you'll see photographs of these and plenty of discussions on how it's done, and that the people that are very best at steam are doing this. The modern fire tube boilers that are round, this is boiler like you see in an apartment house, they're smaller as well. So if you think of the water being at the top of a circle, as you raise the water line, that space that the steam has to disengage becomes smaller. Common sense. So how we pipe these things is very, very important. And also the piping in the building. Steam can go two ways. You could have parallel flow. That's where steam is traveling in the same direction as the condensate, or counterflow, which is what we have in one pipe steam heated buildings, where the steam's trying to go up a pipe as the condensate is trying to come down a pipe. So when you look at this, you say, if I were steam, what would I do? If I were water, can I get out of the way of the steam? And if their apartments are not heating or the offices are not heating, I look at stuff like that. Think about the arsenal. Look for things that shouldn't be there. Think about air. If I were air, could I get out? And notice too, on all these old jobs, we had asbestos, which used to be a nice thing. It was the magic mineral. Love it. And asbestos was something that we learned could kill us. Asbestos could kill us. So we want to get rid of that. And often when we get rid of that, we find out, oh, it's wonderful now, the basement is warm. So let's not insulate the pipes. But when you remove the insulation off the pipes, the heat loss of that pipe increases by 5 times. So suddenly the piping in the basement, the risers, anything that had asbestos removed becomes a radiator. And the boiler is the same size. So you effectively, by removing the insulation, undersize your boiler. And then we wonder why we have no heat up on the 5th floor. It's because the heat's in the basement. Didn't used to be in the basement, used to be on the 5th floor. Take the asbestos off, the heat's now in the basement. See? And what's the solution to that? Most knuckleheads will go and raise the pressure, which just makes the boiler run longer. And that might be enough to get the heat up to the 5th floor, but a tremendous cost in terms of fuel. So insulate pipes, supplies and returns as well. Even though the returns don't have steam in them, they've got water. And the cooler that water gets, the more corrosive it gets, because when we boil water, we get carbon dioxide coming out of the water, and that forms carbonic acid, which is what eats through steam pipes. So insulate the pipes. And don't exceed the carrying limit on any of those pipes. And that information you can get in books like The Lost Art of Steam Heating or Greening Steam, or just go on the wall at heatinghelp.com, which is the bulletin board on the site. Very, very well visited by many very smart steam people. And you can ask questions there. If I want to add or move a radiator, what do I have to know? How much can I add to this line? Speaking of which, the load. Steam is a gas that desperately wants to be a liquid. On the planet Earth, it's not normal for steam to be a gas. And steam, when it leaves the boiler, is coming in contact with all that cold metal. And it has to take that metal from the ambient temperature up to steam temperature. And that's going to use a lot of energy. And we call that a pickup factor. So in addition to what the radiation is condensing, the pipes are also condensing. So when we size a replacement boiler, we have to be very cognizant of how much radiation is out there condensing steam. So unlike with a hot water heating system where we do a heat loss on the building, with steam, we generally measure the radiators because the boiler's ability to produce steam has to match the system's ability to condense steam. And nowadays, when we look at boilers, you really can't replace the steam boiler by looking at the boiler that's there, because it could be wrong. Boilers were oversized for a lot of reasons. Back in the early days of steam, in the manufacturer's textbooks and the literature, they used to tell people that if the husband was going to make a fire, because it was always the wife's job, it was like keep the home fires burning. The women made the fires. And they said, if your husband is going to make a fire, you should increase the size of the boiler by 70%. So that was for the husband, right? So we got a boiler almost twice as big because he doesn't know how to make a fire. And then as time went by, those boilers were burning coal, and we decided that we're going to now burn oil. So there was never a reliable factor to go from coal to oil. So they would measure the grate area, because in a coal boiler, you got this grate that the coal is sitting on. So they say, okay, let's allow so much oil burning per square foot of grate area. They were making that up as they went along with a generous oversizing measure. And because the people that were putting in the oil burners were also going to sell the oil. So now that time goes by, and now we're replacing the oil boilers with gas boilers, and the gas guy is getting the size of the boiler by looking at the nozzle on the oil burner, which was sized by the other guy that oversized it. And then it go back to the husband who didn't know how to make a fire. So you see we get in trouble? So it's best to measure the radiators and then add a suitable pickup factor. And again, lots more in heatingup.com. I've only got a limited amount of time to talk to you today, but there's plenty of information on this. The pressure that we run, back in the day, they used to put 60 pounds of pressure in the boiler. I mean, at the radiator. And the radiators were made out of thin metal. They put 60 pounds of pressure in there thinking that was a good thing. And that led to a lot of boiler explosions. In the 1880s, we were blowing up buildings one every 36 hours. We leveled a building somewhere in America. This was really bad for business. So a group forms, it's called the Carbon Club. And they were all the boiler manufacturers got together. They called themselves the Carbon Club. And they met in the Murray Hill Hotel, which used to be on Park Avenue and 41st Street. They had a meeting there on December 18th and 19th in 1899. And at that meeting, they came up with what became known as the 2 PSI standard. And they said, from this day forward, a steam system should operate at 2 pounds of pressure or less. That's all you need. And the way they did that was they uniformed pipe sizing. So they said, everybody's going to use these pipe sizes for this load, this pipe size for that load, and everybody's going to follow the same rules. So they leveled the playing field where contractors could no longer compete by using higher pressure. And that was what made steam safer, much safer. Many of the boiler explosions stopped after they came up with that in 1899. And this is why the Empire State Building, which does have Con Ed steam and a vacuum system, but the highest pressure they run there, like on the coldest day of the year, is about 1.5 pounds. And that's the Empire State Building. So if you're living in an apartment building and they're running it at 10 pounds, something's wrong. Probably the air can't get out. So the boiler's full of water, or not full. It's, we live in space to make the steam, but you shouldn't need much fresh water if you're returning all the condensate that's coming back. If there's leaks in the system, fix the leaks. Don't just start putting chemicals in there, because the chemicals get a little touchy. If the mixture's not right, or if you're not treating something that needs to be treated, if you're just throwing chemicals at it because the stuff you bought at the supply house is a cool name, then you're liable to get yourself more problems than you had in the beginning. You're liable to get the pH wrong. It's supposed to be somewhere between 7 and 9. If the pH gets too high, if it gets up around 10, corrosion is impossible at a pH of 10. But what happens on the flip side is the water will begin to foam at a pH of 11. And foaming is what happens when you get these very, very tough bubbles on the surface of the water that don't break. And it's kind of like what you see in a hot tub when you turn the jets on. The hot tub pH is typically kept pretty high because people sitting in the hot tub are adding their own particular brand of acid, by not getting up and go to the bathroom. They just do it in a hot tub. However, if the boiler begins to foam like a hot tub, all that water is going to get carried up into the system by the steam, and that's going to give you very, very wet steam, which is bad stuff. And you can see that in the gauge glass, the wet steam. So again, it should look dry above the water line. If it's soaring in over the top, something's wrong with your water. And as I said, if you ask that question, if I were air, could I get out? Walk the pipes, look around, and see if you can get out, and be nosy. I've done that in every building I've ever visited where I was trying to figure something out. It's good to be nosy. It's a great way to get into people's apartments and see how they decorate. So get out there and wander around. It's good to be the heating guy. And know that main vents are aptly named because they vent the main, the big main horizontal pipe that goes out. Off of the main, we've got risers that feed up to the radiators. The risers need to be vented. And also, the radiators need to be vented. So we should not ask radiator vents to take the air out of the main because there's too much air in the main for a radiator vent to handle it. And what happens when you've got too much air is the radiators begin to hiss. If you could hear air hissing out of a radiator vent, that means you don't have enough vents. Because what you're hearing is air under great velocity because it has very few places to go. It's just trying to get out, kind of like locking all the doors except one and then setting the building on fire. You're going to have a riot trying to get out of that one hole or that one door. So if you can hear air venting out of an air vent, that's telling you you need more air vents, because if you've got main vents in place and they're working as they should, you will not hear air venting out of the radiators. They'll be very, very silent. Nice thing for tenants too, because they're not going to wake you up in the middle of the night. Also, if as you're watching that air vent, if it is venting and it's audible, hold a match next to the top of the air vent, or take the air vent off and hold a match next to the hole. And often you will see it will begin to pant, like there'll be a push of air and then it stops and then there's a push of air. But if you hold a flame next to that hole, you'll notice this phenomenon where the flame goes this way when the vent pants and then goes back this way into the hole. And this is the radiator breathing in and out. And that's often because there's wet steam in the system that's, trying to get somewhere, but then suddenly condenses. So you've got this push and then it goes into a vacuum, push and it goes into a vacuum, and the radiators will vent. So that's a good way to check to see whether that's going on. And again, that leads to the piping around the boiler, the quality of the water, the cleanliness of the water, and all ways you could save fuel. It's not normal to have banging and water hammer and all that stuff that's going on in the system. Look for the air vents. Often the air vent might be on a condensate pump or a boiler feed pump in the basement. Those are vented to the atmosphere. But if you're looking at that, be especially careful of where that piping goes, because often the piping comes back from the building. It's coming down from steam traps, and it'll go across the basement floor and then turn upward to go into the inlet of the boiler feed pump or the condensate pump. As soon as you do that, you're creating a U-tube water seal through which air will not vent. And the vent for the entire system is on that tank. And if you build a water seal, the whole building's going to be cold because it's going to be airlocked. So ask yourself, if I were air, could I get out? And then just look, and it'll be right before your eyes. Back in the day when we were burning coal, they used to put main vents at the ends of the mains and feed the main as if it were its own separate thing. And when they switched over to oil and we had automatic heat that ran on a thermostat, they had to be extra careful with that because suddenly you've got the thermostat shutting off before all the air is out. So the guys that were doing the oil heat in the 1930s and the 1940s, they added big, big main vents at the ends of the mains. So when we're doing this, we talk about something called master venting. And I want to, I can't get too deeply into that right now because there's much to it. But if you go on heatinghelp.com and you search for balancing steam systems using a vent capacity chart, balancing steam systems using a vent capacity chart, there will be all the instructions put together by my friends in Cleveland, Jerry Gill and Steve Pajak, who did tremendous study on this stuff and published everything. It's there for you for free. And you will find out how to balance one pipe steam systems and two pipe steam systems so that every radiator gets hot at the same time and at extremely low pressure. Steam traps wind up on the end of the radiators. Steam traps trap steam, but they also vent air through themselves to an air vent somewhere. So you got to be conscious of that. And you have to know that steam traps need maintenance. No steam trap lasts longer than 10 years. So you have to get those things tested. On a radiator, you can check the temperature. You should see a temperature difference of 10 to 15 degrees across the trap when the system is up. If you're tired of radiator traps, consider using orifices in place of the radiator traps. That's something that I've seen done. I didn't used to believe that this could be done very successfully, but then there's a plumber friend of mine, Paul Shea, who's got a plumbing company in New York, and he took me to a building some years ago, and he showed me how in this big loft building in Lower Manhattan that had these long radiators that ran down the whole side of the wall. He just removed all the steam traps, and he put in, I believe it was an 1/8-inch hole, an orifice in the steam supply valve, which is just like a washer. It's got an 1/8-inch hole in it. And that only allows in a certain amount of steam. So the steam kind of gets backed up trying to rush through this little hole. And that takes the place of the trap. And Paul would go in and do that. He would vent the ends of the mains like crazy. I mean, some of these things he would build like a heating menorah, and he'd have like 10 big main vents at the end. And then he would get rid of all the floating thermostatic traps in the system and replace them with what the dead men used to do years ago. Instead of using that floating thermostatic trap, they used a U-seal. So you come out at the end of the main, you've got all your air vents there, and then the pipe drops pretty much down to the basement floor and then turns and comes back up, and it goes into the return that is dry. So that fills with water, and the steam won't go beyond that point as long as you keep the pressure low. And when Paul was showing me these buildings, they were running on like ounces of pressure, way less than a pound of pressure. They were quiet, they were fast. The people saved a lot of fuel. And he did very well with that, because one owner would tell the next owner, and he was just working his way through most of Lower Manhattan at the time. So something to think about with traps. The building itself, the radiators are on the windows because around 1911, and this pretty much started in Chicago, they stopped using double windows, which came before single pane windows. The double windows were there first. And we stopped using those because they said, now that we have steam heat, we can have these single pane windows, the sash windows, which allowed oxygen in, beautiful fresh air. So ventilation is very necessary. Our building on 20 West 44th Street has the same steam system that went in 1890, and it's the same windows too. And we open those windows and we get fresh air. And we just got inspected by the city, and they gave us a very high rating for energy because we don't have a mechanical ventilation system. We're depending on the windows to let in fresh air. Good stuff. Now, I mentioned vacuum earlier, and I got to tell you one more thing about vacuum. I've got a buddy up in Massachusetts. His name is Igor. Igor is from Russia, and Igor is a very, very smart man. And Igor's done a study of steam heating, and he looked back on the days when we used to have a system called the Paul system, invented by Andrew Paul, where he would have a device that would attach to the radiators. The General Society had this system at one point, and you would use steam through an ejector that would create a vacuum in the basement, and you would suck the air out of all the radiators by these little tubes that came down. So this captivated Igor, and he decided that he was going to experiment with this, and he invited me up to look at what he was doing, and I was astonished because what Igor is doing is, he calls it next gen vacuum heating. And I think this is something that everybody needs to look at, because steam in a vacuum is not 212 degrees. It's not 215 degrees. It could be down like 150, 160 degrees, depending on how deep the vacuum goes. So Igor gets a little vacuum pump like you'd pick up at Home Depot or Granger or someplace like that. And he's got plastic pipes coming back from the radiator, clear plastic tubing. And he sets the boiler up, and he starts the vacuum pump before the burner starts. And the vacuum pump creates this deep, deep vacuum throughout the whole system. Then the burner comes on. Now you start making steam, but you're not making steam at very high temperature. You're making steam like a hot water heating system would run on. You got steam going up there like 170, 180 degrees, and it's going into radiators like European style flat panel radiators that he was using. And I was astonished. There was no sound. It was fast because it's steam going into a vacuum, and everything would get hot, and it's all running at low temperature. And the best part was, I'm giving you a real brief explanation of all this, but the best part was that the burner shuts off, the heat continues to go up because it's chasing this vacuum, and then as the vacuum starts to die off, instead of the burner coming back on, the vacuum pump kicks in again, drops the pressure, and you start to make this low temperature vapor steam again. I'd never seen anything like this. If you told me about this, I'd say that's not possible. But I saw it with my own eyes. And the stuff that he's done, this saves 35% on retrofit, 50% on a new system. And if that ain't sustainability, I don't know what is. So what I would suggest is go on heatinghelp.com when we're done, and just in the search engine, look for sustainable steam. Because Igor Zadanovsky and Viktor Zelmanovich and George Belenko, all these Russian guys, these guys have more degrees than a thermometer. They are very smart people. They put this paper together, which Aaron posted on Heating Help, and it's well documented, it's well footnoted. You could read exactly what they're doing there. So search sustainable steam. And when you're looking at any job, I'll give you this last advice. If you don't know what you're looking at, put your hands in your pockets and back slowly out of the boiler room or back away from it. And then go to heatinghelp.com, take a picture of the thing, go on there. That audience is so huge. You will get an answer as to what it is, and probably shown the manufacturer's installation during, or the patents for the thing within minutes. It works that fast. So there's that. And the last thing I want to mention is, I'm a storyteller, and Erin asked me to work with her on a podcast, which is available anywhere there's podcasts, called Dead Men Tales. So that's just started. I think we got 5 of them up there now, and many, many more to come. So if you're interested in learning more and hearing some great stories, Dead Men Tales podcast. So that's it. My time's up. I'm open to any questions you have for me. And please, only questions I have answers for. Thank you. Karen?
Hello, sorry.
Don't be.
Hello, Dan. Hi, Dan.
Hi, Karen.
Okay. Thank you so much.
You're welcome.
I'm going to, Victoria and I will say more about this at the end, but we'll get straight into the Q&A. And in fact, well, this is the question actually from Victoria. When did you start writing books? What motivated you to start writing books?
I worked for a manufacturer's rep. I started in 1970. I left there in 1989. And in the early 80s, I was writing a newsletter for them, because I've always been a writer. And it was called The Problem Solver. And we sent this out to 5,000 contractors every month. And in fact, I made that mailing list because it was way before the internet. I went to the library in every county in and around New York and New Jersey and wrote down the names of every contractor that advertised in the Yellow Pages. And that's how we put the mailing list together. But it became really popular. And I was writing under in the corporate we. My name was never on anything. We were on a job, and this is what we saw. And I would tell these anecdotes as I've just done. And that became real popular. So I asked my old boss if I could write a little book about steam heat. And it was called the Steam Book, this little orange book that they put together. And my name wasn't on it because the boss thought that, people would bother me if my name was on it. And then they proceeded to sell like 10,000 copies of the thing and thanked me very much. Well, I was an employee. So that was, it dawned on me that I could make a living writing about this stuff. And in 1989, I left them, and Marianne hadn't worked since our first daughter was born. We had 4 daughters. We had a total savings of $5,000. I had to buy a car, I had to buy a overhead projector and all this stuff to do seminars. And we basically wound up in debt. But I said, I'm going to be a writer. So Marianne said, how long is it going to take you to write this book? And I said, about 6 months. It took me 3 years. And in the meantime, I was doing consulting and I was doing seminars. So we got by. And when that book came out, no publisher was interested in it because, who's going to buy a book about steam heating when they haven't installed this stuff since the 1930s, right? So So we printed 5,000 copies of that book, and they delivered it to the house. We didn't have an office or a warehouse. They put them in my living room. And I was writing for the magazines at that point. So we advertised that we've got this book, and we sold 5,000 copies of that book in the first 6 months. And we sold them in every single state, including Hawaii, which flipped me out. And then right behind me over there on the wall is a framed purchase order from NASA.
Fantastic.
NASA, the rocket scientists needed to learn about steam heat.
That's amazing.
And that book, we printed that book again and again and again, and Aaron continues to sell it. And it was just like this massive success. And then I wrote another, I think 26 books after that.
Wow.
So, why I did it? Well, I had to feed the family. That's why I did it. Plus I loved it. I loved every minute of it. And I met so many wonderful people along the way who taught me so much, because it was just me reading old books and going to old bookstores and just talking to the old coots and, really spending time asking them questions until finally, I got it. I got it. Once I got it, I'm not an engineer, but once I understood it, I felt I could explain it.
Well, you've done that prolifically, and you've what knowledge and expertise you have to share. Just a couple of practical things for the audience. One, if we prefer you don't use the chat, if you just use the Q&A. And two, raising hands are sort of harder to see. We really need you to type your question in. So if you wouldn't mind doing that, thanks so much. But we have quite a few questions, so I'm going to start on those. And in fact, I'm going to use, this is from Aidan Madery. Are there any steam systems that use a fuel other than oil or gas, like steam generated by electricity?
Yeah, but that's on a huge scale. That would be district heating. So, for instance, the Coors Brewery in Colorado has the most efficient cogeneration plant in the world, because they make electricity for the whole town and for the factory, and they make high pressure steam, and that's to make the beer. And then the brewery itself is the condenser for that huge boiler complex that they have, and they're making electricity by burning coal, and they're using the steam to make beer. So, but you see that on larger scales. Con Ed makes steam, of course. They're not the plants that are making the steam are not making electricity, but on Heating Help, there's a cool a picture of 90 men having a luncheon inside one of those Con Ed boilers. They were the engineers that commissioned that boiler. It's from a magazine in 1930, and 90 men have lunch inside the boiler. Search that. It's a great picture. And the story in there is just wonderful.
It sounds fantastic.
Yeah.
I must say, one thing about this format, it feels like you're speaking directly to me, and I'm sure everybody else feels that. So this is terrific. This is a question from one of our attendees. In old Manhattan residential buildings, how can you control the heat within the apartment? The heat can be quite dry. Also, how can you add humidity to the room to eliminate the dry heat?
The second part first. They're back in the old days, they made these galvanized pans that would hang on the back of the radiator or on the front of the radiator, and you just put water in it, and the heat of the radiator would cause the water to evaporate. You could also just put a pot of water on top of the radiator, and that will evaporate as well. Or you could buy a relatively inexpensive humidifier, that's what we do here on Long Island.
Right. Okay.
And to control the heat, it's going to depend on whether you have one pipe steam or two pipe steam. One pipe steam, you could use a thermostatic radiator valve that goes between the radiator's air vent and the radiator itself, and that will keep the radiator from overheating. So it's an alternative to opening the windows. on two pipes, and that's something any handy person can do themselves. You screw the air vent off, you screw the thermostatic radiator valve into the radiator, and then the air vent goes back into the other side of the thermostatic radiator valve. Two-pipe steam is more complicated because the thermostatic radiator valve replaces the supply valve. And here you have the chance of breaking pipes and things like that. So you've got to have tools, and you have to have a little bit of skill with piping to do something like that. But also typical New York stuff, if it's a co-op building or an apartment building, there's often not enough incentive to deal with the people that are uncomfortable. Unless everybody in the building is unhappy, nobody does anything, particularly in co-ops, because it could be pricey. And often this work on steam systems, like repairing traps and all, it gets done during the winter, which is the dopiest time of year to do it, because you can't do it all in one day. And if you do some of the radiators, replacing the traps, and not all of them, those new radiator traps are going to be destroyed that first night as soon as the steam comes on, because steam is in the returns and it's going to break the radiator traps.
Right. Okay.
So there's much to be done, but I mean, you could also look at what's controlling the system, what's turning it on, turning it off. Many of the buildings have a heat timer like controls. That's a brand name, but these are devices that sense the outdoor air temperature and the indoor conditions, and they will turn the system on to run for so many minutes out of an hour, depending on the weather conditions. The challenge with that, though, is the whole thing is being controlled by what's called a thermistor, which is a electronic device that senses temperature. And that has to be placed by somebody somewhere out in the system. Ideally, it should be somewhere out at the end of the main. So it can tell the control, okay, steam has reached the end of the main, which means it should also be going up the risers to the radiators. It's now time to start a countdown to shut off for the burner, depending on how cold it is outside. If it's 40 degrees outside, or is it 10 degrees outside? That determines the cycle length. But I have seen those thermistors installed on water pipes, sewage pipes, gas lines. And I said to the guy, the gas line is never going to get to be 215 degrees. Why did you put the thermistor on the gas line? And he said, well, we're trying to save gas. So you see? But the challenge here too is that once the thermistor gets placed, it often gets covered up with insulation, and nobody leaves a note where the thing is. And it's not like you have a fob that you can press and say, where's my car? Because the thing's somewhere out there in the piping system, and that's a big challenge. So you take it as a system. If you have somebody do a walk through the building who understands about steam, they look for stuff like that.
Right. I just want to remind the audience again that it's difficult to answer your question when you raise your hand. So if you wouldn't mind typing in your question. But I also want to mention, Dan, we now have 27 questions. Okay. And I don't think we're going to get through all of them. So I want to apologize in advance to the audience members who don't get their questions answered tonight. But I believe, as been mentioned a number of times, that I'm sure they can direct their questions to heatinghelp.com.
Yes, if any of you just go on the wall at Heating Help, and there's a section there called Strictly Steam. Within the wall is the bulletin board. If you ask the question there, you'll be answered within minutes by the sharpest people I know far more about steam heat than I do. And the heatinghelp.com is one of the oldest websites in the heating industry. I mean, it goes back to 1997. When we started heatinghelp.com, Amazon had 350 employees. So, it's that old. And we've developed a culture there where, people don't make fun of each other. People don't talk pricing. They don't talk politics. They just talk about heating. And it's very respectful to anybody, and everybody's welcome, whether you're a homeowner or an engineer or an industrial person, everybody is welcome there.
Right. Well, what a tremendous resource. This is from Jacob Ford. Do you get the sense that longevity was an intentional goal of old steam system design, or just a coincidental side effect of materials used and ongoing maintenance?
I think it's such a simple system to begin with. I mean, really the only moving part is the steam and the water. So in most of these systems, the controls are simple, And the metal used to be a lot thicker. The boilers used to be much thicker, so they lasted longer. Same went for the radiators and the piping. The stuff that we use nowadays is thinner and I mean, I'm all for modern heating. I love all the new stuff that comes out, but we look at boilers now as having a lifespan of 10 years. That's it. The modulating condensing type boilers, they've got 10 years, and you got to take good care of them during those 10 years. So compare that to say the steam system in the General Society, which is 130 years old and still running, and still providing.
Absolutely.
I looked at the heating system in the Dakota, which is from 1884, and these are rich and famous people that are living in apartments that are worth $1 gazillion, and they're being heated by a steam system that was installed in 1884 and still running. Which is incredible.
Yep, absolutely.
Well, the Dakota, by the way, had a steam engine that made electricity for that building, and they used the waste steam through that pole vacuum system that I described that Igor's now involved with. And when other buildings were built around the Dakota, they provided steam and electricity to those buildings. So the Dakota was one of the oldest cogeneration plants in the world. Tidbit.
Yeah.
New York City lore.
Incredible. The next question actually links in with that. This is from Edward Haas. So are there any vacuum systems installed in NYC? And you can say what buildings. Well, obviously you've just said one building that has it. Are there many others?
Not the next gen stuff that I was talking about with Igor, but he'd love to have somebody want to try that there. But vacuum heating, as we have in the Empire State Building, oh yeah, they're all over the place.
Right. And another question relating to that. Do you think that this is about what you've just said, what you were talking about with Igor? Does just reverse engineering the VariVac system, which was used by Dunham Bush throughout the country,
yes,
and is it still being used today in new buildings?
I don't believe in it's being used in new buildings. I think that's a business that is just strictly maintaining and replacing parts in the buildings that it exists in. I haven't heard of anybody putting it out into a new building.
Right.
That is what my years ago when I worked for the manufacturer's rep, we sold a lot of steam stuff, and I said to my boss, "How long can this go on?" And he said to me, "It's a profitable non-growth business." And I said, "We sell air vents by the truckload." And he smiled and said, "The one pipe steam air vent." He said, "As long as there are painters, we will sell vents." Because they paint over the hole. And then the radiator doesn't get hot, and they have to replace the vents. So that we had that conversation probably in 1972, and the business goes on. So it's very long term. I mean, the city just announced that they're going to NYCHA is going to get rid of the steam, and they're going to put electricity. They're going to electrify all the city housing, which is going to be interesting to watch, because I'm not sure that the buildings have enough wiring to do that, and I'm not sure that Con Ed has enough electricity to do that if the whole of New York City goes electric. I mean, as it is now, we shut off the air conditioning during the summer, right? Imagine if we had to shut off the heat.
It's certainly very interesting choice.
Yeah. And again, we got General Society got a very high rating in terms of efficiency on that, because we don't have a mechanical ventilation system, so we have no fans running. We have no pumps moving water around. We've got this very old, very efficient steam system that's quiet, silent, and balanced.
Dan?
Yeah.
That's because of you and your involvement. When you came here in 2015, it wasn't as perfect as it is now. So thank you.
You're welcome.
That was all you. So.
Well, that's because you people are irresistible, and when I visited that building, it was like having a blind date with a building, and it was love at first sight. So, and for those of you that don't know, Victoria's been coming to the building since she's how old?
11.
11. Victoria is a past president of the General Society, the only woman to hold that office since 1785. And she's my mentor as the current president. And her dad was the president.
19.
So it's a beautiful thing, the General Society.
It really is, and it's all, as I always say, collective contributions, 235 years of collective contributions, and everyone made a contribution, all of the people that have come through. So, and again, Dan, I can't say enough when you arrived on the site. For those of you listening, we had gotten a quote to revamp our steam system, and like manna from heaven, Dan, after much urging from people that have said, oh, you need to meet Dan Holohan, he would love this building. And, you know, I heard it for years, and then finally I said, I need to meet that Dan Holohan. And he reviewed what we were going to do. It's very serious, actually. It was a good firm, and Dan said, do not do that. That will harm your system and have an adverse effect. And this does go on. So it is important for everyone to do their homework. And I can't say enough about heatinghelp.com. I am not from the heating profession, but I do love seeing those exchanges in terms of how people passionately answer questions. And they really, it's very academic in the best of ways. So I urge you to go to that resource.
And just so everybody knows, what we did in the General Society building was we brought it back to 1890. So we took out the stuff that people had put in over the years that shouldn't have been there. So it's again it was like the arsenal, you know, traps that are in the wrong spot. So we basically put the whole building back to 1890 when it was new, and it runs like it ran when it was new. So this is magnificently sustainable. You don't have to spend a fortune either. I mean, we did that with very little expense.
Well, again, thanks to you. And I learned that water hammer, I grew up in a New York City apartment. So when you heard all that noise, it meant the heat was coming on. And I grew to accept it. But I learned, of course, through Dan, that that's not normal. Not to hear any noise.
Yeah, and we have no water hammer at all now.
We have no water hammer.
Yeah. Good.
Thank you.
Question from Sean Dresler. When you talk about wet steam, is that basically the same as carryover?
It's, the carryover, which is often called priming, is when you get the steam dragging the water up into the building, and that creates wet steam. So once it leaves the boiler, if it's got too much water in it, the liquid water will rob the latent heat out of the steam, and the steam will become water, and then it doesn't go anywhere. So that's caused by often dirty water, too much chemical, bad near boiler piping. You got to follow the manufacturer's instructions for installation with these modern boilers, because the piping separates the water from the steam. The boiler used to do that internally. It can't do it anymore.
Michelle Guterres asks, I'm trying to find sustainable steam in spiral bound. Any ideas?
I'm sorry, I missed the...
I'm trying to find sustainable steam in spiral bound. I don't know if she means a book.
Oh, the lost art of steam heating? When Aaron bought the company in 2016, when I retired, Amazon became the publisher of the books. They make the books, and Amazon doesn't do the spiral binding. So sometimes you'll see it on YouTube. I mean, not YouTube, but eBay. You know, people will sell a copy on there, but we don't have the spiral binding anymore.
Okay. This is from Nora Lavori. Steam is so comfortable and reliable. Why are people turning to radiant and forced air?
Probably because they've never experienced steam. I mean, I know people that go from steam heated buildings to furnaces, and they're miserable. You know, steam really is to me is the most glorious, comfortable thing to be around. It just glows. And you know, people worry about the kids touching the radiators, but you know, I was one of those kids, and I only touched it once.
Yes, that's true.
So I wasn't a stupid kid, you know. And as I recall, I think my mother smacked me for touching the radiator, so it was double trouble.
Now it's nearly 7:05. There are still another 28 questions. We take about another 10 minutes of questions down.
Of
How do you
course.
feel? Okay,
Of course.
see how many we can get through. This is from Greg Ty. 2 pipes versus 1 pipe system. Is either more efficient than the other?
2 pipe is mostly for big buildings, and the 1 pipe is for smaller buildings. So efficiency is, I'm pausing because efficiency makes me smile. It's as compared to what? That would be the question that I would ask. Because there's so many things that could make, like if you took two buildings, this one has 2 pipe steam, that one has 1 pipe steam, they could be as efficient as each other if everything as it should be. But you could plug 1 vent on either one of those systems and make it completely inefficient. So it's got a lot to do with who's taking care of the building.
Right.
Who's the super? Does he know what he's doing? If they bring in a contractor, does the contractor know about steam heat? So there's no easy answer to that. It's not like, yeah, this is better than that.
Okay. This is from Phil Coakley. You've mentioned steam traps a few times. Mr. Coakley has a 1 pipe system and he's aware of vents on all the mains and radiators, but not aware of any traps.
It wouldn't be on 1 pipe steam. That's strictly a 2 pipe steam thing.
Okay, well, that's a quick answer to that question. Now, this question is from, I have to say, James Dean. I'm sure, Mr. Dean, you do get teased about your name, but it is a fantastic name to have. What is the working life of Dan Foss steam radiator vents, and are they serviceable?
Yeah, they're serviceable, and their lifespan is great. I mean, I visited Dan Foss's plant in Denmark and several of them, and they are a world-class company that it just makes really, really good, dependable, reliable stuff. So good stuff.
Right, good. Barbara Banks wonders, are the steam boilers still in the Woolworth building? And do you know if the coal was automatically fed?
I have never been in the Woolworth building, I'm ashamed to say. So I don't know.
Well, hopefully someday in the future,
yeah,
you'll have a look at their boilers in the Woolworth building, perhaps.
Yeah, they wouldn't. I mean, I don't think anybody's burning coal in New York anymore. Okay. They're not even burning number 6 oil. Right. Not supposed to be.
Edward Haas wonders, can you tell us about a Hartford Loop?
Yeah, that was mandated by the Hartford Steam Boiler Insurance and Inspection Company in the early 1900s. I forget the exact date. I should know that. But prior to that, they used to bring the return came back along the floor in the basement, and it's called a wet return because it's always filled with water. Anything below the water line of the boiler is always filled with water, and that pipe would corrode because, again, the condensate is acidic. When you boil water, you push carbon dioxide out of the water. That mixes with the water on the return line, and you get stuff that has got pH like Coke. It's Coca-Cola. Like it's acidic. So that eats through the pipes. And in the days when they were burning coal, if that pipe broke, you'd suddenly lose all the water out of the boiler because it would flow out through that pipe. And this is prior to us having low water cutoffs, because you don't get a low water cutoff until 1923, I believe. And that they had to wait for the oil burner to be invented before they could invent a low water cutoff to shut off the oil burner. In the coal days, there's nothing that's going to shut this off because it's a coal fire. So what would happen is the boiler would lose its water. Somebody would notice that there's no water in the boiler, and they would add water to the boiler, and the boiler would explode. So the Hartford Insurance Company was left holding the bag. So they mandated this thing that we call the Hartford Loop, which says that when the pipe comes back from the wet return, it has to rise up and enter the boiler through the equalizer, which is a pipe that comes from the header of the boiler down into the return, and you enter that equalizer just slightly below the boiler water level. And that gives you the luxury of some time, because if the pipe should break, then there's still going to be water in the boiler, because now you've got this loop seal, the equalizer, and the water's only going to drop to the point where that equalizer connects with the returning pipe coming back. So that became called the underwriter's loop or the Hartford Loop. And these days it's still mandated. A lot of people say it's not necessary anymore, but I like to see it remain there, because there's still a possibility that the low water cutoff might not cut off, could be plugged or clogged or not wired, or it could fail. And the Hartford Loop is a good insurance policy to kind of back you up should your low water cutoff not work.
Right. This is from Jerome McManus, someone new to steam heat. Where would you recommend I start to understand and improve my system? Mine is gas powered.
I would get the book that I wrote called We Got Steam Heat. I wrote that for homeowners, and it explains everything, how everything works, what could go wrong, and it's also got a lot of focus on how to hire, like what you can do yourself and what you should not do yourself, and how to hire a contractor that knows what he's doing, and how to know whether the contractor knows what he's doing, the questions to ask him. So it gets you away from the knuckleheads.
Right. Okay.
Yeah, so I would start with that, and that's on Amazon. It's also on heatinghelp.com, which goes through Amazon. So We Got Steam Heat.
Right.
Thank you.
This is from Siri Dimtruck. Hello, Dan. What do you think about the Con Ed Steam Heating or Columbia University District Heating System and its future?
It's the biggest in the world. It's the biggest steam system in the world, and it's relatively expensive. But when you factor it against what's involved in buying, maintaining, and feeding your own boiler, if you're not interested in that, it's a pretty good deal. I mean, we're on Con Ed at the General Society, but in our basement are two boilers that are 10 feet high, 10 feet wide, and 20 feet long. And the building was built around those boilers. They're not going anywhere. They're enormous. And those boilers were actually made on 34th Street, if you can believe that, right down the block from where Macy's is, and brought over. So we, rather than this before I was involved, but rather than try to maintain those boilers, which were coal, converted to oil, the society went to Con Ed. So the steam comes in and it's always there, and they come around to start it up in the fall and shut it down in the spring. So it's a matter of weighing one thing against the other. District heating is becoming very, very prominent worldwide, not with steam, but with hot water. And in Europe, it's particularly popular and growing like crazy and very exciting, because they're using other things rather than fuel. They're burning garbage. Most of Copenhagen runs off of a steam plant that burns garbage. They actually have to import garbage to burn. And there are other areas popping up where they will use solar panels, and they will store the heat underground during the summer, and then bring it back up through a district heating system. This is hot water during the winter. So the earth is a tremendous heat sink. So you take this hot water that's being heated by the sun, you stick it into the ground. It stays hot. And then when it gets cold outside, you just run the pumps, and it takes that hot water through that stored hot earth underneath and puts it into people's homes. So, there's so much going on. There's a Paris in the train system. They use the body heat of the people passing through the station. They also do this in Stockholm, and they put that heat into a district heating system to heat people's apartments and houses. The body heat. The Mall of America in Minnesota has no heating system. That entire complex is heated by bodies. So there's much going on in the world of energy that is not fuel-based. It's not oil, it's not gas, it's not coal. it's heat pumps, it's geothermal. I mean, I visited Iceland, and no house has a chimney. I mean, nobody's burning fuel there. Everything's coming out of the ground. It's magnificent.
Well, I think we're just going to take, and thank you, Dan. We're just going to take a couple more questions. This one's from Mark Chisholm. Do you plan to still be teaching your knowledge at the General Society? I truly hope so. Does that mean you'll come back for another lecture next year, Dan?
Well, Karen, if you ask me, you're impossible to say no to. So of course. Then thank you, Mark.
And this then will be our final question. Well, see, I'm going to take two. First of all, this is from Lev Chesnov. This will be a quick question to answer. My name is Lev. I've been in your seminar. Are you planning to translate your books to another language, Russian, for example?
No.
Okay, well, that was a quick answer. And this is our final question for tonight. And again, I apologize to all the people whose questions we weren't able to get to. Did you see any cool steam-driven refrigeration in any particular building? I seem to remember it in Macy's and B. Altman's. This is the question from our attendee.
Not that I recall. And I've been kind of out of the loop for the past almost 5 years now anyway. So, and especially for the past year, I've been sitting here in this room. So not that I recall, but I should go look at something like that. You've all been wonderful. Thanks for hanging out with me.
Again, as I said, we obviously could have been here for hours, but as I say to the audience members whose question was not answered tonight, some of the questions we'll be able to print out, and I will send them to Dan. But really, as been mentioned, heatinghelp.com will be the best resource to get the information to those questions.
Absolutely. And I can't see any of you, but I'm imagining you're the best looking audience I've ever spoken to. So thank you for taking care of yourself.
I think that's completely true. And Dan, I just want to say thank you so much. It's just terrific. It really is a very special thing when you come back each year, and really you are the font of all knowledge on steam heating and hydronics. And it's so very, very generous of you to share your knowledge with our audience. So thank you very much. And I'm sure Victoria would also like to say a few words.
Thank you.
Thank you, Karen. And Dan, I just want to add to that. I mean, where would the industry be without you, that you chronicled all this in all of your writings, and you've left, there's a tremendous amount of knowledge that has been such a gift to the industry. And it is always so enjoyable for me to meet Dan's fans in my work. All I have to do is mention his name, but I always hear the story of how Dan, these are engineers, it could even be a homeowner at a lecture, but how you help them solve their problems and their issues and make them better engineers and all of that. And I do want to acknowledge some of our faculty that might be on the call tonight and were part of our STEAM team. John Catania joined us tonight, Alex Weiss, Joe Marciano, so they were on the call. And they teach, as many of you know, at our Mechanics Institute. And we also have a new faculty member who is a third generation Mechanics Institute graduate. And that's Matt Jitley, who I'll close by saying Matt Jitley referred to Dan as the Derek Jeter of the industry. It says it all. So thank you, Dan.
Thank you. I've always believed that the reader's more important than the writer, because I already know what I know. And now you know it too. So share it. Share it. That's the greatest gift you can give me. Thank you.
Thank you, Dan.
That is a wonderful note to conclude on. And I know there was one final slide we were going to put up, and I don't know, Angelo, if you want to do that, or I should. Angelo's off screen clearly, or yes, and here we go. So this this is again to remind you for the answers to your questions to go to heatinghelp.com. Again, I would like to thank Erin Holohan Haskell for her also tremendous help for this evening. And Dan, you know, what can we say? It's just it's such a pleasure to hear you speak, and you know, you always make the information so entertaining, and that is much appreciated. I want to thank our audience this evening, and I do just want to mention that we have two upcoming lectures. One is on Tuesday, November 24th, and that is saving the Battery Maritime in downtown Manhattan. And on Tuesday, December 1st, we have a completely and radically different topic, inside paragraphs, typographic fundamentals. So with that, I'm going to say good night to all of you, and thank you so much again for attending, and a huge thanks to Dan. Thank you very much. Good night.
Thank you. Good night.